SGAcl is an extensive topic, so I could just go on and on with more sessions about SGAcl, but I have to stop at some point in order to continue with the anchor topics. So this will be the last SGAcl session where I will try to cover some loose ends and try to talk about topics that I haven't talked yet about SGAcl. So let's do it in a question and answer basis. So first of all, what is a campus fabric? With a campus fabric, we are going to have devices that are connected to each other in a way that it resembles a fabric. This is a marketing term on one side because Cisco likes to use the term fabric for their products. Cisco used to name fabric the way that their electronics work for their original series of switches. So we're going to call this a fabric because Cisco likes to use that term, and because this is somewhat a fabric, this resembles somewhat a fabric, the way these devices are connected together, and that will be the marketing approach. But the technical approach is that we are going to have a fabric when we have an underlay and we are running certain protocols in that underlay in order just to transport traffic, and we have an overlay where we are going to have tunneling technology that will create tunnels on the fly in order to actually move a layer 2 or layer 2 traffic that belongs to end users or end devices. So let's go to the next question. What is the difference between an SDAccess network and a campus fabric? The difference is having a catalyst center, formerly known as DNA center. So if you add a catalyst center, formerly known as a DNA center, to your campus fabric, then your network becomes an SDAccess network. Let's go to the next question. What are the features that you lose when only having a campus fabric opposite to having an SDAccess network? So as we just said, you can have just a campus fabric if you have an underlay and an overlay working on your network. But if you add the Cisco Catalyst Center, formerly known as DNA Center, you make your network become an SDAccess network, and you are going to lose features if you don't have that. So you can have a running network, but you will lose orchestration. You will not have orchestration, and you will not have assurance. So your network will not be an intent-based network without if you don't have your catalyst center. So let's go to the next question. Is it possible to have a fabric without LISP and VXLAN technologies? Yes, several network administrators are currently migrating their traditional networks into something that is known as EVPN with VXLAN. So in this case, they are not running LISP in the overlay as the control plane. They are running this other standard protocol that is based on multi-protocol BGP. So this is a way of doing this without going for the Cisco solution. Another question here: are intermediate nodes overlay devices? The answer is no. the intermediate nodes are only underlay devices because the only database they manage is the global routing table that comes from ISIS that is running in the underlay. And they are only there to move packets from one point to another. So they are only forwarding packets, and they are actually unaware the nature of these packets. They are the intermediate nodes do not know whether they are forwarding packets that are actually VXLAN packets, and they don't know they are forwarding packets that they are actually LISP messages. So the intermediate nodes are not overlay devices, they are underlay devices. The next question is, do intermediate nodes have an underlay and overlay tables? No, they only have underlay tables, which is the global routing table that comes from ISIS. Let's go for the next question. How do edge nodes and border nodes store underlay and overlay tables? So the edge nodes will store underlay information in the RIB, which is actually the global routing table that comes from ISIS. So this information comes from ISIS in the underlay. But given these devices also are living in or performing duties in the overlay, they will have another database that comes from the overlay. This database will be the LISP cache. And this database comes from, obviously this comes from LISP. And the information is basically arriving as the form of map reply message. So remember that edge nodes and border nodes usually have to query the control plane node sending a map request message, and when the control plane node answers, it will answer with a map reply message. The edge nodes and the border nodes will store that information in a cache. This cache will live there for 24 hours. So just remember that border nodes and edge nodes have these two separate databases in order to do the forwarding for the packets. Do we still use CEF and FIB within the fabric? Yes. For instance, we are going to take the global routing table that comes from the underlay, that it will create a routing table, and then we are going to feed this into the FIB in order to move packets as fast as possible using CEF. So we are still using CEF within the fabric. Next question. Why do the RLOC included in the map register message, which is an overlay message, must exist in the global routing table? So there is a relation between the overlay and the underlay in order for this to work. Underlay, and this is the RLOC. The RLOC information must exist in both in both universes. So this is where the two universes touch. So we can put it in another way. So we have the overlay here, and we have the underlay here, and we have the RLOCs here that must exist in both universes. So for instance, let's put an example here. Let's imagine that this edge node has this loopback IP address, for instance, 10.0.0.1, and for some reason I forgot to advertise this loopback IP address into the ISIS domain. I forgot to do that, so all the other devices in their routing information database, they will be missing this IP address. They will not have that IP address. So that is a problem in the underlay. So what will happen in the overlay if this device sends a map register message to the control node saying, hey, I just got a device that has the endpoint ID 10.1.1.1, and I want to register into the overlay. So it will have to send a map register message to the control plane node, and it will say that this device that has this IP address is connected to the device that has the IP address 10.0.0.1. So if we didn't do a double check if this RLOC exists in the global routing table, this entry will land into the host tracking database. And if there was another device here, for instance, device that has the IP address 10.1.1.2, and this device wanted to communicate with this one, then this other edge node will have to create a VXLAN tunnel, and it will have to send a map request to the control plane node. The control plane node will say, yes, I have that destination device here in my host tracking database, and the device or the RLOC that you must send your packet to is this one. So at that moment, this edge node will have to use its underlay routing information base in order to look for this IP address, but it will not find it, because remember that we said that we originally had that error. So this device here will not be able to create a VXLAN tunnel. It will fail. So that is the reason why the RLOC included in a map register message, which is an overlay message, must exist in the global routing table, which is an underlay table. Hope that made sense. Let's question. For wireless deployments using a fabric, is 1550 enough for the MTU? Remember that with traditional networks, our MTU was 1500. So the question is, for wireless deployments using a fabric, is 1550 enough for the MTU? No. The answer is no. Remember that when using a fabric, we are going to add 50 bytes for the VXLAN tunnel. But when using wireless, remember that wireless require the usage of a cap web tunnel. And we are going to transport this cap web tunnel using VXLAN. So that means that we must add the header that belongs to VXLAN. And then we'll have to add about 16 bytes for the wireless cap web tunnel. Cap web. So we'll need more than this. Next question. what happened to broadcast, non-unicast, and multicast in a campus fabric? Remember that in traditional networks, we will call that broadcast, non-unicast, and multicast, that layer 2 switches used to flood over complete VLANs. So we are not, we are simply not flooding them. So the fabric will make efforts in order to translate these boom messages into unicast. In order to not flooding them into the network. So by default, that is the way it works. So when a broadcast arrives here, then this edge node will query the control plane node. The control plane node has a mapping between IP addresses and MAC addresses. So you can think of the control plane node as having a huge ARP cache for the whole fabric. So if a device here tries to figure out what is the MAC address of another device, what is the MAC address of another device, then the control node will provide that information. So there is really no need to propagate broadcast when or non-unicast when we don't know where a particular device is located, because in the fabric we always know where devices are located, and we always know their mapping between their IP addresses and MAC addresses, and that information is stored here in the control node. So we don't really need broadcast to flood broadcast and unicast within the fabric for that reason. So the answer is we are not going to flood them. We are going to translate them into unicast. But if you have some issues, for instance, with silent devices that still need to get broadcast flooding into them, but we can enable. But we can enable layer 2 flooding if you want. And the way it works is that in the underlay, we are going to create multicast network that is going to simulate this flooding. So we are going to enable multicast in the underlay in order to enable flooding in the overlay. So let's go for the next question. What is the benefit of using a scalable group access control list if I still have to create IP-based access control list in my firewalls and other devices outside the fabric? So this question makes a lot of sense, because remember that one of the selling points of having a fabric is that I'm going to forget about IP-based access control list. I am going to forget about that, and I'm going to use now a scalable tag group access control list, because it is more manageable, more human friendly, and but that will only work within the fabric. So if I have, for instance, firewalls that live outside my fabric, I still have to reflect a lot of these rules, and I will still be using IP-based access control list here. So the benefit is that in the future, these firewalls that live outside the fabric in the future will start using a scalable group access control list. This technology will start to grow the fabric, so more devices will integrate into the fabric and they will be aware of the scalable group tags. And as time goes by, you will start replacing an IP access control list and you will start using scalable group access control list as your devices that live outside the fabric start to integrate with the fabric. Next question. If H nodes take over many of the roles of access switches, adding many more, so if H nodes are taking the role of access switches and board and intermediate nodes and take over the roles of distribution switches, who take the role of core routers within the fabric? So I think the question is quite transparent. The border nodes will take over the roles of core switches. The border nodes is where we are going to do most of the routing when it comes to the fabric. They will do a lot of routing, talking to fusion routers. They will do a lot of routing when talking with external networks. And they will be my rendezvous points if I want to enable multicast within the fabric. So you have to think about the border nodes as your core routers with fabric networks. Next question. What about multicast in SGAcl? This is a huge topic. Let's try to summarize it. We have two options with enabling multicast within the SGAcl. In an SGAcl network, we have this technology that is known as head-end replication, and we can also have a native multicast. Head-end replication is an overlay solution. And in this case, we're going to translate multicast messages into unicast messages. So as multicast message arrives into the fabric, for instance, in this example, the border node will translate that into one or several unicast messages to all the devices that were registered to receive this multicast information. The other option is native multicast. With native multicast, we're going to have an underlay solution. We are going to enable multicast in the underlay. So, for instance, we can choose the border node to be a rendezvous point for a multicast groups, and then we are going to leverage this underlay multicast into the overlay. Next question. What is a critical VLAN? You might face the issue when for instance, your ICE servers or at least your PSN persona is unavailable. So if the PSN persona is unavailable, then when a device connects to your network, you will not be able to perform network access control. So you will be unable to identify this device. So one option will be denying this device access to the network, but another option is placing this device into a particular VLAN that we're going to call critical VLAN. So what is the critical VLAN? The VLAN is where you're going to place your devices that were not able to authenticate to your network because your PSN was down when they got connected to the network. And this VLAN is usually number 2046 and 2047. And you must make sure to provide this VLAN with the adequate permissions. The minimum set of permission available because you have not authenticated these users. That is what a critical VLAN is. Last question. Can you explain the official Cisco SGAcl architecture diagram? Remember that when Cisco released SGAcl, they released this diagram, this architecture diagram, talking about the physical layer, network layer, controller layer, and management layer. So my question will be, I could explain it, but I won't. It is only making SGAcl more confusing. You just went, you were trying to learn SGAcl and you saw this, you will be completely confused. Cisco is completely contradicting everything we know about layering networking with this architecture diagram. It doesn't make any sense. Cisco should fire the engineer that came up with this abomination. So I'm not going to try to even go into this. This is nonsense marketing Cisco stuff. That's it.